Alright, so what we're going to do is we are going to find the equations of the sides that contain AB, BC, and AC. And I should have said of the lines. Forgot that part. It's early in the morning. Remember what my rule is. No math should be done before 10 a.m. Remember that when you get to college. No math should be done before 10 a.m. in the morning. Make sure you're absolutely awake and actually had some sleep before you got here. This usually isn't the time for it. Now, for AB, what I know is A has the coordinates 3, 3. B has the coordinates 0, 4. I also figured out the slope of AB was equal to negative 1/3. Now, does anybody remember how you figure out the equation of a line if you know 2 points and a slope? Yes. You can use y equals mx plus b. Okay. You're on the right track. You basically, this comes from the slope formula itself. This comes from, this is just where you know the slope and the y-intercept. So this is the y-intercept. Now, the problem with this guy is you don't know b. So we know m, we know an x and a y. Actually, we know two of them that are on the line, but we don't know b. That's the problem with this one. We can figure it out. I'll show you how to figure it out using this one. For this guy, the only things that we're ever going to fill in is this, this, and this. Those three things are what we fill in. So the nice thing is we know m, and we know 2 points that we could use. Now, I'm going to start with this guy. This is what we call the point slope equation. And ladies and gentlemen, this thing is something that will be with you in every single math class that you ever take from now on. Linear functions, linear equations, and that's what we're talking about. We're talking about lines right here. These are the lifeblood of algebra and calculus. Believe it or not. We end up analyzing all sorts of weird graphs just by finding lines, tangent lines to be exact. Now, I know my m in this case is negative 1/3. That's what we figured out from the problem. And what point do I want to use? Either one. Let's use A. So we're going to use 3, 3. I'll move that over a little bit. Could we have used B, 0, 4? Absolutely. So all you do, take the formula and plug in the points. I know y1 is what value? 3. What's the slope? Negative 1/3. And then I'm going to put x minus the x value, which is 3. So when you're using this, the first step is always substitution. You're going to put in your m, your x1, and your y1. That's what you always do first. Second, you're always going to distribute. And you're always going to distribute right here, the negative 3 across here. So you'll get y minus 3 is equal to, what's negative 1/3 times x? Negative 1/3 x. Now, we could have put x in the top and get negative x over 3, but it's better this way because we can see our slope. There's our slope, so we know our slope all automatically. And sometimes when you put x in the numerator, the slope kind of gets covered up a little bit, so we don't want that to happen. And so then we're going to go plus negative 1/3 times negative 3. So simplify this down. That's negative 1/3 x. Well, what's 3 times 1/3? Not 3, but 1. Because they're reciprocals of each other. So when you have a number times its reciprocal, it ends up being 1. What's negative times negative? Positive. So we got positive 1 in that case. And if you didn't see that, you get 3 over 3. Because 3 times 1, you always multiply a whole number times the numerator. So 3 times 1 would be 3 times 3, which is 1, which is what we got right there. Now, do we want to leave it like this? Now you want to move it, you want to move the y sub 1. So, in this case, I want to add 3 to both sides. Negative 3 plus 3, that's 0, so I get y is equal to negative 1/3 x. What's 1 plus 3? Plus 4. Now, this is in perfect form because this is in what we call function form. Whenever you have y equals something, it's in function form. So once you have that, you can put it into a graphing calculator and graph it. You can do all sorts of things with it. So you want to put things into function form whenever you possibly can. Yes, sir?
Isn't that y equals mx plus b now?
It is y equals mx plus b.
Instead of doing all that, really just plug in the slope.
Well, the thing is, we didn't know b. So if we went through and said, all right, well, why don't we take this guy and let's try and use a again at 3, 3, and use m is equal to negative 1/3, use y equals mx plus b. And we better end up through all of this right there. We better end up with the same equation. Now, what's my y value? 3. And, well, for the first step, solve for b. 3 is equal to m, which is negative 1/3. What's my x value from the point? 3 plus b. Well, what's negative 1/3 times 3? They're reciprocals again, so when I multiply them, I get a 1, but it's negative times positive, so it's going to end up being negative. So 3 is equal to negative 1 plus b. Now I'm going to add 1 to both sides. Four is equal to b. So I figured out b. Very happy. Now, part 2. Substitute in mb, or replace m and b in the original equation. Y is equal to negative 1/3 x plus 4. Isn't that the same thing we got over here? Okay. So we're able to find the different lengths. Now, I'll let you work on finding the lengths of the other two, or the equations of the other two. I'm not gonna do that right now, just because for the sake of brevity on the video, I want you to use this structure to find the equation for BC that contains BC and AC.